So, thank you very much for having me here. Um, in my view, the most important words in science are not eureka or anything at all similar to that. In my opinion, the most important words in science are "that's funny." It's a time when a discovery, good or bad, is starting to be made, and recording these laboratory moments are absolutely essential for an R&D organization. My name is Mark Auty. I'm a laboratory automation engineer in our data and automation team at Unilever. We help our scientists to make discoveries to create the next generation of products. The R&D program within the company is far more dynamic than it ever used to be as we adapt to a rapidly changing market. This means that a capability that once would have been slowly built up and widely used for many years needs to be created and put into service over a much shorter timescale than ever before. Our automation strategy, therefore, needs to be very nimble and adaptable. Simply put, the traditional ways of doing lab automation are holding our scientists back. It's very seductive to buy into a suite of tools built by a particular manufacturer. I'll try not to name any names here. Everything should just all work together perfectly. And if it doesn't, simple phone call will make good things happen. Well, that is until you discover that the capability you want isn't and won't be provided by the offering. Or the supplier decides that for strategic reasons, they're going to change the product range, or simply to not support your system anymore. We've lived this dream in the past and it isn't entirely pleasant. Suppliers quite understandably want to build walled gardens to keep the customers inside, and it helps them to maintain product quality and consistency. But we've found that this isn't always sustainable given our ways of working, certainly not everywhere. Sometimes you need to have a bespoke automation to accomplish a task, and integrating this into someone else's system can be a really quite interesting challenge. I will apologize to the control engineers for this bit. But at an engineering level, equipment integration and operation, it's just a controls problem. It doesn't matter how easy it is to overcomplicate these things, it's controls. With instruments being SiLA enabled, we've changed Unilever's control paradigm for lab automation. No longer does the integration software hold the device drivers, which, let's note, these were generally written by the authors of the controller itself. This means we're swapping out one integration tool that speaks SiLA for another one that speaks SiLA becomes possible. I won't say it's necessarily trivial, but it's many times easier than getting a whole new system written by a different manufacturer and then having to test and debug every single layer in this functionality. Much of the work is already done with the tried and tested SiLA drivers. We've successfully changed the integration layer on a workflow using SiLA-enabled devices, and it wasn't that bad. Costs are lower as the drivers are already there and free to use by an integration tool on the network, and testing the new controls while the original ones are still in place is beneficial to continued operation. Another advantage is that upgrading the hardware to provide new capabilities is easier with this modular approach. It's a network protocol, so all the new code may even be on a different computer, which, when you're making these changes, is potentially a lifesaver. An integration tool can be anything from a whole automation control system, or it can be as simple as providing a different user interface to a piece of kit. It could give benefits, for example, over the originally provided one, potentially for accessibility, or to provide a connection to a LIMS or other system so that information doesn't need to be keyed in again. SiLA has allowed us to start designing our labs as we want them, and this is key to our automation journey. It is, of course, important to recognize that not all equipment at the moment has a SiLA driver available out of the box, and we've taken a mixed approach to solving this problem. Some drivers I write myself, or I get a student to do it, and this does take some technical skill, and we are very fortunate within Unilever that we've got resources to do this in-house. We also use drivers written in hackathons. Other times, when we outsource the activity to a third party, or work with the device manufacturers directly, and this is particularly if we want is non-trivial. As SiLA makes the automation challenge modular, All or part of it can be outsourced as needed without affecting the overall control philosophy. So the scientist is always in control. Our R&D operating model may be a little bit different to some people. Very rarely does the LIMS system directly trigger an action. Generally, it provides information based on a user's request. This is where the scientist is in charge, augmented by the technology, not dictated by it. In this regard, I don't see a LIMS system as anything other than a device. It's just like any other lab piece of lab kit. It takes commands and outputs a result which can be processed and lead to other actions. We decided within the team to standard on Python as the house language. This is because Python's easy to learn and it's easy to use, which dramatically lowers the barrier to producing useful tools. We've had year-in-industry students go from minimal Python to producing useful drivers in a very short timescale. The embodiment within SiLA makes it very easy to get a basic driver working quickly, and this has been absolutely essential to our success. This was the case for our in-house created LIMS system. We could simply provide a SiLA gateway to the existing API with all the important features such as authentication still in place. As it was our own system, we could predict any quirks, so the driver became very reliable and predictable really quite soon. For our proprietary LIMS, we found things to be a little bit more complex, as, to be honest, the SiLA way is not necessarily the manufacturer's way. Situations like this, cultural and business issues, can get in the way of a good technical discussion, but thankfully there's a shared interest in making progress. In this case, we've had the assistance of experts in third-party organizations to help devise a mutually accessible means of providing the capabilities that we and our scientists need. This is still a work in progress, but where there's a will, there's a way, and we are getting there. While scientists still complete manual workflows by physically moving from instrument to instrument, these days really are getting numbered in Unilever as we try and remove the low or non-value adding activities from people's workload. Scientists have got a far better things to do with their time. And we can also eliminate potential sources of error in the process. While automation isn't perfect, and on very rare occasions it does fail, it generally behaves in a reproducible way. And importantly, it provides log files. Humans generally don't provide log files. I'll say again though, the scientist is in charge and the automation is there to help and augment, not to replace. A great example of routine lab work in this context is manually making formulations. This has got lots of accurate weighing and controlling of temperature and mixing, and the apparent simplicity of the activity belies a great deal of skill and experience needed to make a product correctly. Formulations sometimes don't behave as they were designed, or duplicate batches behave differently, and this can be down to small differences in processing, either accidental or intentional in origin. DEFT is a SiLA-based system made by one of our partners and is really helping us to understand how small changes in processing can affect how our products behave, and this insight is helping the whole R&D process. DEFT does this by guiding the scientists through the activity, helping to reduce mistakes and to maintain situational awareness. It records all the instrument's readings so the scientists can concentrate on more important things, and it gives them a chance to see what's happening instead of rushing to the next step. You could ask the question, did you detect that 1 degree exotherm in your mixture? You might not have done, but DEFT did. Importantly, it records the automation quality log file for the whole process, which means that understanding what actually happened is possible with simple data analysis techniques. Being SiLA-based, integrating the new equipment into the DEFT ecosystem is relatively straightforward. With the DEFT experience at one end of the digitized process and fully automated work cells at the other, there's a middle ground where we perhaps no longer think a human should be doing a workflow, and we need an easy path to adding the automation. By incrementally upgrading the lab equipment and data flows to connect via a common protocol, the opportunity to use robotics on a previously manual workflow becomes much more amenable. The technical challenges have for the most part already been solved, as each step is thoroughly tested. Full automation can then be accomplished by effectively building a work cell around the well-characterized workflow, or by using a looser type of integration with mobile robotics, or cobots. This substantially de-risks any future build project by adding improvements step by step. The more SiLA devices you have, the more you can do. Now, I've been working in lab automation for around 20 years. I was involved with the building of one of the very first lab robots within Unilever R&D. And over this time, things have evolved a great deal. I have to say that with the birth of Auty, Industry 4, cobots, and SiLA 2, this is the most exciting and rapidly changing time in lab automation that I've seen. Having a supplier-agnostic standard to facilitate easy control of devices and systems has been a game changer. I now have a new set of tools and techniques at my disposal to meet the business needs and to find new opportunities to help my scientists. So to summarize, I hope this short presentation is giving you an insight into how, and very much more importantly, the why we are using SiLA in our lab automation journey. Writing a basic functional SiLA server is not as daunting as it first seems. The modular and standardized nature of SiLA allows us to integrate our systems in new and more dynamic ways. It allows us to build workflows, testing each level thoroughly before we add the next layer of complexity. This results in rapid deployment and a more reliable solution. We can distribute labor. To separate standards compliant modules, which gives us much greater scalability. We've demonstrated that we can easily replace any component in the integration, which provides a pathway for easy updates, and it gives us some insurance against supplier lock-in or adverse business decisions. Following the standard allows us to use many of the same software components for human, cobotic, and robotic activities. This provides an overall simplification to our systems, and it gives operational benefits for the lab management team. So this concludes my presentation, and I'd be delighted to answer any questions that you can have. Thank you very much for listening.